Hi, this is a FreeCAD tutorial for beginners where I will show you step by step how to get started with FreeCAD and how to begin creating your own 3D models. FreeCAD is a fully free parametric CAD system for 3D modeling, and anyone can use this system. To use FreeCAD, simply download and install the program. To download FreeCAD, go to freecad.org, click Download Now, and select the installation version for your operating system. Download the file, install the program. The installation is standard, and you can start using FreeCAD to create your own 3D models. Next, launch FreeCAD. FreeCAD will start with this startup page, and we will begin this tutorial by working in the Part Design module. Here you have a list of available modules, and select the Part Design module. This is the module where we can create our own 3D models based on 2D sketches. This is a method commonly used in 3D CAD systems. In this module, we work on features and parameters, which means that at any stage of 3D modeling, we can go back to a previous stage and change selected parameters. We will get to that later. Start a new project. Click this button or this icon. We have a new project in the Part Design module. By default, we have the Tasks tab open, but we will more often use the Model tab, as here the history of operations will be displayed, and step by step the additional features we add to the model will appear. At this moment we have an empty project. To start a project, we can do it in two ways. The first way is simply to click the Create Sketch button and then select the sketch plane. I will now exit the sketch and pay attention to what has been created. A body has been created which represents a 3D object. It is a single 3D solid. Inside the body object we add more sketches, more operations, and step by step we build a 3D model. Now I will delete this body by selecting it and pressing delete. We can also do it by clicking the Create Body button. The body has been created. In this body we can create a sketch. To create a sketch, click this Create Sketch button. You need to specify the sketch plane. Here we have the basic sketch planes, the XY plane, YZ plane, and XZ plane. In this case, we will select the XY plane. To select the sketch plane, click on that plane with the left mouse button. Notice that we have been switched to the Sketcher environment. We now have access to other commands. The Sketcher environment works closely with the Part Design environment. In this environment, we create two-dimensional geometry, from which we will then create a three-dimensional solid in the Part Design environment using appropriate operations. Here we have commands for creating and editing 2D geometry. We also have commands related to constraints, and we will get to that shortly. However, in the first step, let's go to this menu. And I have these two options checked here. Make sure these options are also checked for you. The first option is related to automatic constraints. If this option is checked, automatic constraints will be added while creating 2D geometry. The second option is for automatically removing redundant constraints. This option is also very useful because it means that if any unnecessary constraints appear, they will be automatically removed. Make sure you have these two options checked, and now we will proceed to create the first geometry. We will start by drawing a rectangle. Here we have the command for drawing a rectangle, and if you click in this area, we have an additional rectangle drawing command. We can choose either the centered rectangle or the rounded rectangle command. Let's start by selecting the regular rectangle drawing. We draw a rectangle by specifying two corners of the rectangle. We do this by pressing the left mouse button. I click here to specify the location of the first corner of the rectangle, and I click approximately here to specify the location of the second corner of the rectangle. The rectangle drawing command is still active. We can create more rectangles. But if we no longer want to use this command and wish to finish it, we can select another command or right-click to cancel this command. Here I have a second rectangle, and I do not need this rectangle. I select this rectangle, press the left mouse button, and drag a selection window. The geometry is selected, and I press the delete key to remove this geometry. At this moment, we have a rectangle here. However, this rectangle does not have defined dimensions. We can freely change its dimensions. And this rectangle does not have a specific position. We can change the position of this rectangle relative to the origin of the coordinate systems. Based on such a sketch, we could create a 3D solid, but such a solid would mostly be useless since we do not know the exact dimensions of this rectangle and we did not know the dimensions of the solid. We usually design models that have precisely defined dimensions. Such dimensions can be added to the rectangle. Here we have commands related to dimensions. Let's first add a horizontal dimension. Select Constrain Horizontal Distance. Select this side of the rectangle and specify the length of this side as 100 millimeters. Click OK. I right-click to cancel this command. Now, the length of this side has a defined value, and I cannot change the length of this side. I can still change the position of the rectangle and change the length of the other side. However, now let's choose the second dimension. Constrain vertical distance. Select the second side of the rectangle and enter 80 millimeters here. Then press Enter and right-click to cancel this command. Now, the dimensions of the rectangle are strictly defined. By grabbing some geometry of the rectangle, I cannot change the dimensions of the rectangle, but I can change its position. Regarding the position of the rectangle, at this moment we can define this position relative to the origin of the coordinate system, but at this point we will pause and we will cover that in the next lesson. In the previous lesson, we started a project in FreeCAD. We created a rectangle and added dimensions. Now we will continue working on this project. The rectangle already has specified dimensions, but it does not have a defined position yet. Now we will define the position of this rectangle relative to the origin of the coordinate system. We can do this using dimensions or using constraints. Dimensions are also a type of constraint, and constraints define the relationships between geometries or between geometries and the coordinate system. If I want to place this rectangle symmetrically about the origin of the coordinate system, I can do this using dimensions. I will add the appropriate dimensions. I will add a horizontal dimension, selecting this point, and here I will enter 50 millimeters, which is half the length of one side of the rectangle. Next, I will add this dimension, also selecting this point, and here I will enter 40 millimeters. I right-click to cancel the dimensioning. And now the rectangle is placed symmetrically about the origin of the coordinate system. However, if the dimensions of this rectangle change now because we can modify the dimensions of geometries, and to change the dimension of some geometry, double-click the left mouse button on that dimension and enter a new dimension value. And now this rectangle is no longer symmetrical relative to the origin of the coordinate system. If I revert to 80 millimeters, the rectangle will be symmetrical, as we have strictly defined dimensions here. This will work only until this rectangle has a length of 100 millimeters here and 80 millimeters here. If we want to place the rectangle symmetrically relative to the origin of the coordinate system, but in a way that is independent of the dimensions of the rectangle, we need to use constraints. I will remove the dimensions. I select the dimension and press Delete. The rectangle no longer has a defined position, and now, to place this rectangle symmetrically about the origin of the coordinate system, we can use the symmetry constraint relative to a point. To do this, we select this point, and this point. When it comes to selecting geometries in the sketcher, we simply select the geometry with the left mouse button. We do not have to hold down the Shift key or the Control key. We just point to the geometry with the left mouse button, and once we have selected these 3 points, we choose the symmetry constraint, and now the rectangle is placed symmetrically relative to the origin of the coordinate system. If I change the dimensions of this rectangle, it will be placed symmetrically about the origin of the coordinate system, because we have a constraint applied here that operates independently of the dimensions of the rectangle. It's worth noting that the sketch has changed color to green. We also have information that the sketch is fully constrained. This means that when a sketch is fully constrained, we cannot freely change the shape and position of the geometry. Now, if I grab some geometry of the rectangle with the left mouse button, I cannot change the dimensions of this rectangle, nor can I change the position of the rectangle. If I want to change something, I need to do it by editing the dimensions, or by editing the constraints. When creating 2D sketches that we will use to build a 3D model, we strive to ensure that the sketch is fully constrained, as it reduces the risk of accidentally damaging the geometry. At this point, if I accidentally grab some geometry, I won't change anything here. I won't change the shape or position of this geometry. And if this sketch were not constrained, if I accidentally grabbed the geometry, I could change its shape and position, which could later impact subsequent stages of the project. We should strive to ensure that the sketch is fully constrained. Based on such a sketch, we could already create the first 3D model. However, let's add 2 circles as well. Choose to draw a circle and create 2 circles approximately like this. OK. I right-click to cancel the circle drawing command. I want the center of this circle to be offset by 10 mm from this edge and 10 mm from this edge. To do this, I will add dimensions. First, I select Constrain Horizontal Distance, select the center of the circle, select this point, and here I enter 10 mm. Next, I select Constrain Vertical Distance. Note that I have the previous command active, but now when I select this command, it becomes active. I select this point, and here I also enter 10 mm. We will also define the diameter of this circle. Choose the Constrain Diameter command here, select the circle, and enter 10 mm as the diameter of the circle. OK. I right-click to cancel this command. Now, I want the diameter of this circle to also be 10 mm. I can do it as I did in this case by using the dimensioning command to define the diameter of this circle, but I can also use the equality constraint. To do this, I select this circle, and then choose the equality constraint. Now these 2 circles have the same diameter, and if I change the diameter of this circle, for example to 12 mm, the diameter of this circle will also change. In this case, I also want this circle to be offset from the edge of the rectangle by 10 mm. I could also add dimensions here, but I can also use symmetry constraint. I select the center of this circle, select the center of this circle, and select the origin point of the coordinate system. Then I choose the symmetry constraint, and in this case, we have not used any dimension. We fully defined the position and dimensions of this circle thanks to the constraints. Constraints often facilitate and speed up the creation of 2D geometry. We will finish this sketch here. Let's close the sketch, and based on this sketch we will create a 3D solid, but at this moment we will pause and do that in the next lesson. In the previous lesson we created a sketch, and now based on that sketch we will create a 3D solid. However, before we proceed to create the solid, take a look at the feature tree. In the feature tree we have a sketch, and now if you would like to edit this sketch, if you want to make any changes here, to edit the sketch, double click on it with the left mouse button or right click and select Edit Sketch. Now we have entered the sketch editing mode and we can make changes here. For example, we can change this dimension. OK, close the sketch, and this is how we can edit the sketch. We will return to making changes and editing sketches later in this training. Now, to create a 3D solid based on this sketch, we will use the pad operation. This is the operation of extruding the sketch, and it is one of the basic operations for creating 3D solids. Select this operation, and here we will specify the extrusion length. Enter 20 mm and click the left mouse button next to this field. The preview has been updated, and when you click OK, this is what the solid will look like. Click OK to confirm, and we have created the first 3D solid based on the 2D sketch. Notice what happened to the sketch. Now in the operation tree the sketch is not visible, and this happened because the sketch was used to perform the extrusion operation, and the sketch is inside that operation. To access the sketch you just need to expand this operation. And here we can edit this sketch again. If you change, for example, the dimension of this side, that change will also be applied to the model, and if you would like to edit the extrusion length, you can do that by editing this operation. Right-click here and select Edit Pad. Here you can enter a different extrusion value, for example 30 mm. We click OK, and the change has been applied to the model. The models we create in this system are based on features and parameters. At every stage of creating a 3D model, we can go back to a previous stage of the 3D model and change the parameters. This is very useful and convenient because if we want to make any changes to dimensions, we just need to change the selected parameter, and we do not have to create the whole model from scratch. And OK, I will end this lesson here, as I would like there to be clear breaks between the topics discussed. Take a break and move on to the next lesson. In the previous lessons, we created a simple 3D model, and at this stage of learning, it is worth discussing navigation issues. When it comes to navigation in FreeCAD, we have navigation styles available in this location. If you click here with the left mouse button, you will expand the list of navigation styles and you can choose the style that suits you. I have chosen the Blender navigation style. When you select a style, if you hover the cursor over this area, a tooltip will appear. Regarding geometry selection, we do this with the left mouse button. If you want to rotate the view, press the mouse wheel and move the mouse, then we can rotate the view. If you want to pan the view, press the mouse wheel and the shift key, and we can move the view in the workspace. And if you want to zoom in and out, we can do this using the mouse wheel. Another useful thing is this cube, where we can set appropriate views. We can do this by clicking on the appropriate face of this cube. We can also use these arrows to rotate the view. Next, we have standard views that we can also use. And here, if an object is somewhere outside the workspace, we can easily display the entire object in the workspace by clicking this button. Okay, those were some quick basics of navigation. When you work with FreeCAD, this will definitely be useful, and you will master it easily and quickly. Now, we will move on to the next issue related to creating 2D sketches. When it comes to sketches, we can create them on the basic planes of coordinate systems, but we can also create such sketches on the faces of the model. Here we will create a sketch on this face. To create a sketch on this face, select this face and choose the Create Sketch command. Now this face is the sketch plane, and we can create additional sketches here. I would like to create 2 circles here, and we will create these circles in a similar way to how we created the circles in the sketch. We select the Circle Creation tool. We will draw 1 circle here and the second circle here. I right-click to cancel this command. Now, I would like this circle to be offset from the edge of this solid by 10 millimeters. I select the Dimension tool, click the center of the circle, and here you see I cannot select this geometry because it is external geometry. It is not sketch geometry. If we want to use such geometry, we need to create reference geometry based on this geometry, such auxiliary geometry. We can do this using the Create External Geometry command. Select this command, click the left mouse button on this line. When this line is highlighted, click here. Right-click to cancel this command. We have created auxiliary geometry here, and now we can use this geometry. I will select dimensioning again. Select this point, and enter 10 millimeters here. I select the second dimension, select this point, and enter 10 millimeters here. Next, I select the diameter dimensioning tool, select this circle, and enter 10 millimeters as the diameter of the circle. Okay, I right-click to cancel this command. Now, just like before, I select the center of this circle, select the center of this circle, select the origin of the coordinate system, and choose the symmetry constraint. Here we have this circle already symmetrically placed relative to the origin of the coordinate system. However, this circle is not yet green because it does not have a defined diameter. Therefore, I select this circle, and choose the equality constraint. We have a fully constrained sketch here. Close the sketch, and now you will learn another operation. Based on these circles, we will create holes in this solid, and this is done using the pocket operation. Select this operation, and here we can define the depth of this pocket. You can also change the parameter values in such a way that when you hover the mouse cursor over the parameter field, you can scroll with the mouse wheel, and then the parameter value will change. We can also enter a specific value here, and then that value will be applied. However, in this case, I would like to have these holes go through the entire solid, so I can use the operation type here. I choose the through all type, and the holes will be created through the entire solid, regardless of what the thickness of the solid will be. Because now if I set the dimension parameter and specify a specific dimension value here, meaning the thickness of this plate is 30 millimeters. I will enter the pocket depth as 30 millimeters here. I click OK, so now everything is fine, but if I change the thickness of this plate, I can also make changes to previous operations at this stage. I right-click here, select Edit Pad, and I will change the thickness of this plate to 40 millimeters. I press Enter, and here the depth of this pocket is 30 millimeters. After changing the thickness of this plate, this hole is no longer a through hole. Therefore, if you want the hole to be through the entire solid, regardless of the thickness of the solid, you can set the operation type to Through All here. And now, regardless of what the thickness of the solid will be, these holes will always be through holes. I click OK to confirm this and edit this operation again, typing in, for example, 50 millimeters. I press Enter, and these holes are still through holes. Depending on what you want to achieve, we can use different parameters here. In the further parts of the course, we will utilize these operations and various options, so there will be more opportunities to reinforce this knowledge. Now, we will move on to creating the next sketch and discussing the next topics, but we will do this in the next lesson. Here we take a break, and we'll see you in the next lesson. Let's continue working on this project, and in this lesson, we will review information regarding the pocket operation and create another sketch on the face of the model. Select this face and choose to create a sketch. Now select the centered rectangle command, which means we will create a rectangle with a center point. Select this command and now specify the center point of the rectangle. When you hover the cursor over this spot and click the left mouse button, the center of the rectangle will automatically be constrained to the origin of the coordinate system. Now specify the location of the second point. Next, let's add dimensions to the rectangle. Here, 120 millimeters. Now the second dimension. And here 90 millimeters. Right-click to cancel this. Close the sketch. And now, based on this sketch, we will add a pocket. Select the pocket operation, and here specify the depth of the pocket. As I mentioned, we can specify the depth by scrolling the mouse wheel, or we can enter a specific value here and enter 30 millimeters. I press Enter, and the last operation has been confirmed. When it comes to creating sketches, in addition to the fact that we can create sketches on the basic planes of the coordinate systems, as you have seen, we can also create sketches on the faces of the model, but it doesn't have to be the top face of the model. It can be any other face. It is important that it is a flat surface. We cannot create such sketches on cylindrical faces, but if we have a flat surface, we can create a sketch on such a face. Now select this face, and we will create a sketch on this face. Select the Create Sketch command, and now we will create a sketch. Here at the beginning, we will create reference geometry. Select the Create External Geometry command, and select this line. Now we will create two rectangles. Choose the Rectangle Drawing command and create the first rectangle like this and create the second rectangle like this. Right-click to cancel the Rectangle Drawing command, and now we will add dimensions to these rectangles. Select this command, select this line, and enter 30 millimeters here. Then, with the command active, select this point, and enter 40 millimeters here. Now select this command, select this line, and enter 15 millimeters here, and right-click to cancel this command. Now select this line, and choose the equality constraint to specify that these lines have the same dimensions. Next, select this line, and also choose the equality constraint. Now select this point, and the y-axis, and select the symmetry constraint to place these rectangles symmetrically relative to the y-axis. Close the sketch, and now, based on this sketch, we will add the pocket operation. As you can see, the pocket operation works in such a way that it simply removes material from the solid. As I mentioned, this does not have to be done on the top face of the model only. It can be done on any face of the model. Here, as previously, we can specify a specific dimension for such a pocket, but we can also use types. As the pocket type, select, for example, to first option, and the pocket will be created like this. We can then choose the through all command, and here the pocket will be created through the entire solid. We also have an interesting option, up to face, where we define the face to which the pocket should be made. However, in this example, it is not fully visible, but in any case, you can define the face to which the pocket will be made. In this case, we will choose through all to create a pocket across the entire solid. Click OK to accept this, and we have something like this. Another basic but frequently used operations in 3D modeling are the operations of adding chamfers and fillets. These are the two operations. They work in such a way that we can add a chamfer or a fillet for one specified edge for several specified edges, or we can select an entire face, and then all edges belonging to that face will be chamfered or filleted. Let's add some fillets and some chamfers here. When it comes to selecting edges, a more convenient view for selecting edges might be the wireframe view. To switch to that view, select the wireframe option here. Now we have a wireframe view, and selecting edges will be much easier. If we are selecting some elements on the model and want to select several elements, we do this with the Control key. We simply press the Control key and select the geometry we want to chamfer or fillet. We select these lines. Here we will add a fillet. Choose this command, and a warning has appeared here. I see that these two operations are selected, so I deselect them. It is possible that this operation was somehow selected, and then with the Control key, I began to select additional geometries. I make sure nothing is selected, and once again press Ctrl to select the edges for the fillet. OK, I choose the fillet command, and here specify the fillet radius 5 mm. I click OK, and the fillets have been added. Now we can select these outer edges, and we do this with the Control key. We select the chamfer command here and specify the dimension of the chamfer as well, 5 mm, and click OK. Now let's switch to the As Is view, and this is how it looks. And if we would like to add chamfers or fillets to all edges of the selected faces, we select the faces, do this with the Control key, choose the appropriate command, and add a chamfer or fillet with a specific dimension. I will cancel this, and I will add a fillet here. And when it comes to adding chamfers, I will select these two surfaces. Here I choose the chamfer, and sometimes it may happen that when we want to add a chamfer, we cannot add a chamfer with a larger dimension. Here I can only add a chamfer with a dimension of 1 mm. At this point, I don't know exactly why this is happening. Perhaps the chamfer would overlap somewhere. Sometimes such situations may arise, but in this case it seems that 1 mm can be left. However, I will cancel this and try to do it in such a way that I will select the edges and try to add a larger chamfer. There may be some error here that is blocking me from adding larger chamfers. OK, I have selected the edges, I choose the chamfer operation, and in this case, I can add a larger chamfer than 1 mm. I will add a chamfer of 2 mm here. OK, now I will try to select a single face. I choose chamfer, and this way I cannot add a larger chamfer, but OK, here I will add a chamfer of 1 mm. And if something does not work, we can always switch to edge selection, and we can select the edges based on which we will add chamfers or fillets. And OK, these are the basics of the basics. We will take a break and move on to the next lessons. The next basic operation for creating 3D solids in 3D CAD systems is to create a solid by rotating a sketch around a specified axis. We will now create another sketch, select Sketch Creation and choose the XZ plane. Then select Rectangle Drawing, and we will create a rectangle whose first corner will lie on the X-axis. Once the X-axis is highlighted, click at this location and place the second point approximately in this location. Next, select Circle Drawing and draw a circle so that the center of that circle lies at the midpoint of this line. Once this line is highlighted, click the left mouse button and draw the circle. Then right-click to cancel the circle drawing command and place the center of the circle between these 2 points. Select these 2 points and then the center of the circle and choose the symmetry constraint. Now we will proceed to dimensioning. First, select horizontal dimensioning. Select this line and enter 15 mm here. Then select this point and enter 50 mm here. Now select vertical dimensioning, select this line and enter 10 mm here. Now right-click to cancel the dimensioning command. Move the dimensions. To move a dimension, simply grab this dimension with the left mouse button and we can change the position of the dimension. Next, select the geometry trimming command and remove those segments of geometry. Here we need to specify additional dimensions. First, select diameter dimensioning and add the diameter of this circle to 5 mm. OK. Now I right-click and gently drag this point, and here you can see that this line is not horizontal. So I select this line and choose this constraint. Now I select this line and choose the equality constraint. Now the sketch is fully constrained. Close the sketch, and now based on this sketch we will create a solid by rotating the sketch around a specified axis. This is the revolution command. Select this command. By default, the vertical axis of the sketch has been selected as the rotation axis, but we have other selection options. If we choose the horizontal sketch axis, the solid will be created this way, and in this case the base z-axis and the vertical sketch axis coincide, so the solid will be made this way. Here we can specify the angle of rotation. If we change this value, the rotation of the sketch will be performed at that angle. I will return to the value of 360 degrees and click OK to confirm. As for creating solids this way, we can also approach it differently. Now I select this solid and press the spacebar to turn off the visibility of this solid, and I will create a new sketch here. Again, I select the XZ plane, and now I will create any shape without focusing on the dimensions. And I have this shape here. I close the sketch, and now I will create another sketch also on the XZ plane. And here I will create a line that we will use as the rotation axis to create a solid by rotating the sketch around a specified axis. I have 2 sketches, the section sketch and the rotation axis. Here I select this sketch, choose the revolution command, and here, as you can see, this solid has appeared which we created earlier. However, now I select the select reference command and specified this line as the rotation axis, and now this solid has been created this way. For now, I will cancel this and once again select the revolution command. Here, I did not select the sketch based on which I would like to create the solid. We can do this here. We have 2 sketches here. By selecting one of these sketches, the selected sketch will be highlighted on the screen, and so I would like to create a solid based on this sketch. I click OK, and here, as you can see, this sketch has disappeared. By default, the vertical axis of the sketch is selected and the solid that we previously created has appeared. Here, if I switch to selecting the axis about which the sketch will be rotated and choose the Select Reference command, the geometries appear in the workspace, and now I can specify this line as the rotation axis. Based on these selections, the solid will be created. I click OK, and this is how we created this solid. Now I will delete this solid. And now I want to check how it will look if I want to create a solid based on this sketch by rotating this sketch around the z-axis. I will remove this operation, press delete here, and this operation has been removed while the sketch has not been deleted. So once again, I select this sketch, choose the revolution operation, and here by default it worked in such a way that based on this sketch a solid was created by rotating this sketch around the z-axis. Here I can also choose Select Reference, and I can specify this line as the rotation axis, and based on that we created this solid. And as for this operation, next to Extrude, this is one of the basic operations for creating 3D solids in 3D CAD systems. We will finish this example here, and now proceed to the next example. Just like in the case of the extrusion, where we create a solid by extruding a sketch, we have the pocket operation, where we remove material based on a sketch. Here we can also create a solid by rotating a sketch, as well as remove material by rotating a sketch around a specified axis. Now I will move on to the next example. I will create a sketch on the XY plane. I will create a circle with a diameter of 100 millimeters. OK, I close the sketch and add an extrusion of 50 millimeters. Now I will create another sketch, this time on the XZ plane. I select the Create External Geometry command to create reference geometry, and I will create some shape here. Something like this. The dimensions at this point are not significant. I close the sketch and now I will remove material from this solid based on that sketch. I select the groove operation. Here, the vertical axis of the sketch has been selected as the axis of rotation by default. In this case, this axis coincides with the base z-axis, and we have created something like this. I click OK, and in this case, based on the rotation of the sketch around the specified axis, we have removed material from the solid. This operation is also one of the basic operations for creating 3D solids in 3D CAD systems. As for these operations, we can combine them. I will now move on to a new project. I will create a sketch on the XY plane. I will create a rectangle with dimensions of 120 by 100 millimeters. I close the sketch and add an extrusion of 10 millimeters. Here I would like to create a sketch on a plane passing through the center of this solid. However, now when I select sketch creation, I can only choose the basic planes of the coordinate system. Of course, in this case, we could create the sketch in such a way that the center of the rectangle coincides with the origin of the coordinate system. However, sometimes there may be situations where it will not be possible to use the basic planes of the coordinate system. In that case, we can create construction planes. One way to create a construction plane is to create a plane in such a way that we select two faces of the solid with the Control key, and then we select the Create Datum Plane command. The plane has been created in such a way that it passes through the center of the solid, but not in the way we would like. However, we have the option to rotate this plane around the selected axis. We can rotate this plane around the x-axis by 90 degrees. And now the plane looks like this and passes through the center of the solid at this point. I click OK to confirm. Now on this plane I can create a sketch. First, I will create reference geometry to this edge and create some shape here. For example, a rectangle. I close the sketch and I have a rectangle created here. Now, in order to create a solid by rotating this sketch, I need some reference geometry, and I will create this geometry on this plane as well. I select this plane and create another sketch here. I create a line in such a way, close the sketch, and then select this sketch and choose the revolution command. Here, the vertical axis of the sketch is selected by default, and we could leave that. In this case, the sketch will be created relative to the vertical axis of the sketch, and in this case, the base z-axis does not coincide with the vertical axis of the sketch. These are two different axes. Here we can also choose the Select Reference option, and we can specify the geometry regarding which we will add the solid by rotating the sketch. And click OK to confirm. In this way, we have created a solid using two different operations. Of course, we can add more operations here. We can add more extrusions or additional operations that remove material. However, it is important that the next stage of the 3D model touches the previous stage of the model. Here, in this case, if I create another sketch on this plane and create something like this, I close the sketch. Now, if I want to create a solid based on this sketch by rotating the sketch, this solid will not be created. Sometimes an error may appear, and sometimes the entire model may disappear. Something like this is currently not available in FreeCAD. When creating another piece of the 3D solid, it must touch the previous stage of the 3D solid. If I go to edit this sketch and slightly pull this sketch so that it overlaps with this model, I can create another part of the 3D model based on this sketch. I click OK, and in this way we have created something like this. In such cases, it can be useful to hide the visibility of selected features. Here I select the construction plane, press the spacebar, and this plane has been hidden. I can do the same with this sketch. I select this sketch, press the spacebar, and this sketch has been hidden. Okay, those were some basic pieces of information about creating 3D solids in FreeCAD. Now we will move on to the next example. The next operations worth learning at the initial stage of FreeCAD are linear pattern and circular pattern. We will start with the linear pattern. A linear pattern is something that creates a copy of a selected feature in a specified direction. I will create a rectangular box here. I will create a new sketch on the XY plane. I will create a rectangle with dimensions of 100 by 50 millimeters. Close the sketch, add an extrusion of 15 millimeters, and here we will create another sketch. Select this face, choose to create a sketch, and we will draw a slot roughly like this. Now let's add dimensions. The distance from this point to this point is 10 millimeters. The width of the slot is 5 millimeters. Next, we select this dimension, and here we will add the distance between these points as 20 millimeters. The distance from this point to this point is also 20 millimeters. At this point, the dimensions of the slot do not matter much. It is important that the distance from the center of the slot to the edge of this solid is 10 millimeters. Then it will be easier for me to show how the linear pattern works. I close the sketch and will add a pocket operation here. Here I choose Through All and click OK. I would like to get 10 such slots on this solid. I would just like more slots to appear on this solid. Of course, I could create sketches of the additional slots, dimension them accordingly, and add extrusion so that I create these slots already at the sketch stage. But we can also do it at this stage. We can simply add additional copies of this slot using the linear pattern command. To add the linear pattern, select the operation that we want to repeat in the linear pattern. Here we select the linear pattern command, and here we have the feature to repeat. During one pattern, we can add several features that are to be repeated. Then we define the direction of the pattern. Here we have the selected horizontal axis of the sketch, and this axis coincides with the base x-axis. We can either choose the base x-axis or the horizontal axis in the sketch. For me, in such cases, it is easier to define the directions using the basic axes of the coordinate system. So here, I choose the base x-axis so that the pattern is performed along the x-axis. Next, we specify the length of the pattern. The entire solid is 100 mm long, and the center of the first slot is offset from this edge of the solid by 10 mm. I would like the last slot in the pattern to be offset by 10 mm from this edge, so I enter a pattern distance of 80 mm here. I changed the value here, clicked next to this field, and the preview was updated. Next, we have the occurrences parameter, which specifies the number of copies of the selected feature. At this point we have 2 copies, and the first slot is offset from this edge by 10 mm, while the last slot is also offset from this edge of the solid by 10 mm. The distance between the center of this groove and the center of this groove is 80 mm, which is the length of the pattern. Now we can add more occurrences. I will enter the value 10 here, so that I get 10 such slots on this solid. I click OK, and this is how the linear pattern works. It is an interesting option that can significantly speed up the creation of 3D solids in many cases. As I mentioned, such a pattern can be performed for several features at once. Now I will hit Ctrl Z to undo the linear pattern. I will create another sketch on this face. I select to create a sketch and will create a circle here. Similar to the slot, I will add distances. The distance from the center of the circle to this point is 10 mm. Then the second distance, also 10 mm. And let's add the diameter of the circle as 5 mm. I close the sketch and add an extrusion of 10 mm. OK, now to add a linear pattern of the slot and this extrusion, while holding the Control key, I select these 2 operations in the operations tree. By the way, I will tell you that we can change the names of operations. Just right-click and choose the rename option. We can specify our own name for the operation here. In the case of a larger number of operations, renaming can make project management easier. Okay, I go back to selecting these 2 operations in the operations tree. I have selected the operation that created the slot and the operation that created this extrusion. Now I choose the linear pattern command. Here an error appeared because at this pattern length, this element will be made outside this solid, and something like that is not allowed. In FreeCAD, the next stage of the 3D model must touch the previous stage of the 3D model. If I change the pattern length value to 80 mm here, everything will be fine. Note that I did not change the direction of the pattern. The horizontal axis of the sketch was selected by default, and the direction of the horizontal axis of the sketch coincides with the direction of the x-axis, so we can leave that. Here I will also enter 10 as the number of copies of these elements. I click OK, and this is how we created something like this. So as you can see, the linear pattern operation, creating such elements where the selected feature is repeated several times, can significantly speed up and facilitate the creation of 3D models. The circular pattern operation works in a similar way, and now we will move on to this operation. Create a circle with a diameter of 100 mm and now add an extrusion of 10 mm. OK. Now on this face we will create another sketch. Select Sketch Creation and we will create another circle with a diameter of 10 mm at a distance of 40 mm from the origin. Close the sketch and let's add a pocket through all. OK. And now based on this feature we will create a circular pattern, and as you might guess, the selected feature in the circular pattern will be repeated around the circle. To add a circular pattern, select the Polar Pattern command. Here we specify the pattern axis, which is the axis around which the subsequent copies of the selected feature will be made. In this case, the axis perpendicular to the sketch is selected by default, and here this axis coincides with the base z-axis. Next, specify the number of occurrences. Enter 10, and already in the preview you can see how it will look. We also have the angle parameter here. We specify the angle at which these features will be made. If I change the value to a different angle here, those copies of the feature will simply be distributed at that angle. I will return here to the value of 360 degrees. And this is how it looks. Click OK, and this is how the circular pattern works. Similar to the linear pattern, in this case we can also add a circular pattern for several features at once. I will press Ctrl Z to undo the circular pattern, and here I will create another sketch. I will create something like this. OK, I will add an extrusion. And now based on these two features I will create a circular pattern. I click OK, and this is how the circular pattern command works. As you can see, in some cases this operation can also significantly speed up and facilitate the creation of 3D models. The next operation that allows for the creation of interesting shapes is the operation of extrusion through profiles, and now I will show you how it works. Let's create a sketch on the XY plane. Let's create a circle here with a diameter of 50 millimeters. OK, close the sketch. Next, let's create a construction plane. Click this icon, and a construction plane that coincides with the XY plane was created. But here, let's add an offset in the z-axis of 50 millimeters. And click OK. And now select this plane, and we will create another sketch on this plane. Let's create another circle here. This time, let's create a circle with a diameter of 80 millimeters. And close the sketch. I will turn off the visibility of this plane. I select this plane, press the spacebar, and we have two sketches. Now, with the Control key, I select these two sketches. I select the first sketch, then the second sketch. And here we have an operation called Additive Loft. Select this operation and click OK. This way we can create a solid that is formed by extruding through profiles. In this case we had two profiles, and something like this was created. Now I will press Ctrl Z. Let's now add another construction plane. Click this button, and here a construction plane was created. However, in this case, as you can see, these commands are grayed out, and here referencing is active. We can simply select this circle as a reference circle to create such a plane. This, in this case, does not matter. And here we set the offset value to 100 millimeters in the z-axis, so as to create another plane in a different location. And click OK. Now on this plane we will create another sketch. And here, for example, let's create a rectangle. The dimensions don't matter much for now. Close the sketch. I will turn off the visibility of the working plane, and now I select all these sketches and choose the Additive Loft command. Click OK, and this way something like this was created. Of course, there could be many more profiles for extrusion, and this way we can create quite interesting shapes. As for interesting operations, another interesting operation is profile extrusion along a path. Let's move to a new file and create two sketches here. Let's create the first sketch on the XY plane. Create any polygon here, something like this. Close the sketch. We will extrude this profile along a path, so now we will create another sketch, this time on the XZ plane. And we will create a polyline here. Approximately like this. Okay, let's also add fillets in these corners. Let's enlarge the radii of these fillets a bit. However, here we don't have a constraint, and I would like this line to be a vertical line. Therefore, I select this line and choose this constraint. And here let's change the fillet values a bit. Let's simply add dimension radii. And now I select these two radii and add an equality constraint here. I just want this transition to be quite smooth. I close the sketch and now I select the profile sketch. Next I select the additive pipe operation. Here I click the object button to indicate the path along which this profile will be extruded, and I select this sketch. I click OK, and this way we created something like this, meaning we added the extrusion of this profile along this path. This is another operation that greatly expands the possibilities of creating 3D models in 3D CAD systems. If we talk about basic operations, I would like to show you one more thing here. Let's create a sketch on the XY plane and create a rectangle of any dimensions. Close the sketch and add an extrusion of 50 millimeters. Now, I would like to create an element with walls of a certain thickness, and we can easily do something like that too. We just need to select the wall or walls that we want to remove. In this case, I will select this wall and choose the thickness operation. Choose this operation, and here we specify the wall thickness. Let's enter 3 millimeters. By default, this thickness is added outward, but by checking this option, we can add the thickness inward. Then this solid will not be increased by the wall thickness, it will have the dimensions we specified when creating the sketch. Click OK, and in this way we created something like this. Now I will press Ctrl Z to undo that. Then I will add a chamfer to this edge. I select this edge and choose the chamfer operation, specifying the chamfer dimension as 30 millimeters. Click OK, and now I select these two edges with the Control key to add a fillet. Let's enter a radius value of 10 millimeters and click OK. Regarding the thickness operation, as I mentioned, we can select several walls. With the Control key, I select these two walls, choose the thickness operation, check Make Thickness Inwards here, and specify the wall thickness, for example, as 3 millimeters, and then click OK. In this way, we have created something like this. Another point worth discussing at this stage is the ability to export the created models to STEP or STL format. The STL format is widely used in 3D printing, and the STEP format can also be used in 3D printing or can be used for collaboration with other CAD/CAM systems. To export the solid created in FreeCAD to STL or STEP format, we select what we want to export, and then from the File menu, we select Export, specify the location and file name. Next, we specify the file type. Here we have a complete list of file types in which we can save models created in FreeCAD. We select STEP, click Save, and the model has been saved in STEP format. Next, I will save this model in STL format. From the File menu, I choose Export, specify the name here, select the STL file type and click Save. Based on this model, we can, for example, prepare a program for the 3D printer. I will run Prusa Slicer, and here I will load the model we created in FreeCAD. I choose the file, click Open, and we have the model loaded. Based on this model, we can prepare a program for the 3D printer. So as you can see, FreeCAD has quite a lot of capabilities when it comes to creating 3D models, and it is a completely free software. We can freely use this system, even for paid projects. We will finish this basic training here, and if you want to learn more, please subscribe to my channel. Here, new videos regularly appear that will help you expand your knowledge of working with FreeCAD, and that's all, and please subscribe to my channel.